Let's summarize what we've been talking about in this section here. We've been computing the instantaneous rate of change of f of x at x equals a. Right? That's what we've been doing. We want to give this a notation. And we'd really like to come up with a better name so that we don't keep having to say instantaneous rate of change over and over and over. Right? That's getting a little exhausting. So what is this? Right? So again, whichever way we're doing this, whichever definition we use, whether it's the h goes to 0 definition of f of a plus h minus f of a over h, or whether we're using the other definition, which is limit as x approaches a of f of x minus f of a over x minus a. Either one of these, we're going to get the same answer, right? The same instantaneous rate of change at x equals a. And what we do is the notation that we're going to use for this is f prime of a. Right? This little apostrophe here that goes on the function, we call that prime. Right? So this thing here is f prime of a. Right? So this quantity here, another way we say this is the derivative of f at, you could say at x equals a or just at a. I'll say just at a, because that's the value here that we're plugging in. All right, so just wanted to sum that up. So when we're doing something like the velocity, right? The velocity is the derivative of the position function. The slope of a function is the derivative of the function at that specific value, right? Marginal cost is the derivative of cost. You'll see that a bit later, right? So it's a lot easier to talk about things like this. It's a lot easier to have a notation for things. So I won't do any example here of this, just wanted to introduce this notation. And we'll discuss this more later.